Assalamualaikum and good evening to everyone. So today we are going to learn into the world of computers, still in the same topic, computer system and the Linux environment. So the continuation from that. Uh, so yesterday we learned about introduction to the computer, but today we are learning the introduction to computer programming. So before we start typing the codes, we first need to understand the why and the how. So many people think computers are smart, but actually they are quite limited on their own. They are just electronic devices with the power to perform difficult tasks, but they do not know what to do. So they basically need us. They need a programmer to tell them exactly what to do by writing programs. So we start with a definition first. So in general terms, programming is the planning or implementation of a task or an event command. So think of it like planning a wedding or a sports event. You are organizing steps to reach your goal or objectives. So in the computing field, programming is specifically the act of instructing a computer to perform specific tasks. So this brings us to two key terms that you will see frequently, which is the computer programming and the program. So what is computer programming? It's the process of planning a set of sequence commands to be executed by a computer. While program, it can be defined as a set of sequence commands that have been determined to be executed by a computer. So essentially, the programming is the act of creating, and the program is the result. So types of programming languages. So computers actually don't sputter English words, even though they display the language of the programming in English. So they actually speak electricity on and off. Okay, to bridge the gap between human thought and computer execution, uh, programmer need to use different tiers of languages. So we're supposed to start with the machine language. So this is the lowest level programming language. So the lowest level is the machine language. It consists of strings of numbers giving machine a specific instruction. So example, a string like this one, 0, 1, 1, 0, 1, 0, 1, and so forth. Okay, so this is the machine language. So it is incredibly fast for the hardware to read, but it's nearly impossible for humans to write without making mistakes because there's so much numbers here. And then assembly language. To make things slightly easier, we created assembly language. Okay. Um, this uses English like abbreviations to represent elementary operation. For example, instead of binary from the machine language, you might write load base pay or add over pay. So take note that computers still cannot read this directly, so it must be translated via assemblers lah, through assemblers, which is why we call it assembly language. And then continue to the high level language. So this is where we will spend most of our time in this semester. These codes are similar to everyday English and use mathematical notation. So for example, languages like we are going to learn, which is C, C++, and Java. So the example code for this showing here is are like gross pay equals to base pay plus overtime pay. So these are so far from machine code, and this high level language like C, C++, and Java, they must be translated via compilers. Okay. So what problems can we solve? Not every problem is a programming problem. A programming problem is specifically a problem that can be solved using a programming language. So what computers are good at? Computers are good at, for example, in mathematical tasks. Okay. For example, adding numbers, small numbers less than 100 is easy for us, but if we try to add more than 100 numbers, it will become difficult and easy to get an error if we calculate it manually. So a computer program can do this in milliseconds compared to when we try to calculate it manually. So unit conversion are the other examples that computers are also good at. They can convert kilograms to grams. They can also do data tracking, counting cars on a highway, or even calculating total rain in a week. Meanwhile, what computers are not good at? Okay, they are not good at in terms of subjective or life choices. For example, finding a life partner, deciding what you want for dinner or buka puasa, or predicting how long you will live. So these lack the logical formulas that computers require. So like I said just now, programming problem. Suppose you want to add 34 and 56. These are the small numbers less than 100. So this is easy if we calculate manually. Okay. But when adding 100 numbers beyond, it is difficult for us. So we need to use like programming, which is embedded in the calculator, or if manual, we need paper and pencil. So this is can be considered as hardware, right? Or the easiest, we can write a program for computer to help us. So that's the point, to solve a programming problem, because not all problems can be solved without computer, and computer also cannot solve every problem in the world. So we have problem, which goes to the, it's up to the human instruction. For example, the programmer, the software engineer, to give instruction for a machine, for example, machine language, this in a form of binary, and then to solve maybe the machine problem. So they use programming language, other programming language. Then C is called basic. We have VB, C hash, Java, Perl, and many others as well. For the steps of programming, we have total 6 steps. So to build a well-designed program, one that is correct, easy to understand, efficient, and reliable, we must follow these 6 steps. So first one is the requirement specification, which is defining the problem and requirements clearly. And then analyze the problem. For the next step is to understand your inputs, outputs, and the processes. For example, like formulas and constraints, which are needed to manipulate the data. And then comes the design. This is where you write the algorithm using a flow chart or pseudocode to represent your solution, followed by implementation of algorithm after designing. So this is the actual coding phase where you write the program. And then testing and debugging. So this is where you need to verify that the program actually meets the requirement. So you need to check for the errors and debugging to meet the requirement. So that in this 5th step. And the final step is the documentation, where you can document the program's purpose, the code itself, and instructions for use. So well-designed program must be correct and accurate, easy to understand, easy to maintain and update, efficient, reliable, and most of all, flexible. So tadi we just learn about introduction to programming. Now, introduction to C programming language, specific to C language. Okay. So programming basics. Computer programs are a detailed set of instruction given to the computer. Programs are constructed based on an algorithm, which is an outline of how your computer program will work. So it's actually an algorithm is an outline of how your program will work. It's a problem-solving procedure that defines what actions to perform and the order they should happen in. So there are 2 main forms of algorithms that we are going to use, which are pseudocode and flowcharts. Okay, so in creating algorithm to solve the problem using algorithm, we must first read and understand the problem. Second, think about different solutions to the problem, followed by design an approach that will solve the problem. Fourth, implementing that design. And finally, test your program to see if it works. This is if needed. Okay, so these are the two main forms of algorithms that we are going to use in our C programming. One is pseudocode and the other one by flowcharts. So pseudocode, this is an informal high-level description written in natural language like English, and they also have mathematical notation. For example, instruction on how to eat a banana. That's for example. Okay. While flowchart is a visual form of an algorithm. So it uses specific symbols which are connected by arrows to show how the logic flows. So when the algorithm is written out as a well thought series of steps, it is called pseudocode. Normally it is written in English language. Okay, we don't write pseudocode in other language than English. So it is written very similar to the way that you would code it into your third generation language, that is C language. This is the example I told before for pseudocode. So create a detailed set of instruction pseudocode that will tell us on how to eat a banana. So basically you will make your instruction as detailed as possible so that even someone who has never eaten a banana before can understand them. Another example for the pseudocode. So this is showing how important is the order. So the order of actions are very important. You need to really write your steps, what you plan to do with the instruction in a right sequence. So look at the Mark Mina example in this slide. So if she gets dressed after taking a shower, she is ready for work. Okay. But if she takes a shower after getting dressed, she will arrive soaking wet and in a bad mood. So the order of action is very important. So the conclusion from these two types of how you write your pseudocode, the sequence will give different results. It's either positive or negative. So just now, a flowchart is a visual form of an algorithm. So it uses specific symbols connected by arrows to show how the logic flows. So the basic symbols you must memorize are like the terminal oval here, okay, which represent the start or end of the program, and a rectangle is actually represent processing part. So this will show mathematical operations like addition, subtraction, and input or output that will be in the form of parallelogram in the flowchart, where the user commonly provides information or the program that displays a result. And lastly, we have like a diamond shape which represents a choice or a yes or no path. So this is how the visual form of flowchart looks like. Okay. So we have the terminal in oval represent the beginning and the ending of a program. And then you will have process in a rectangle shape. Based on here, we have three processes. Normally, it will show the details like mathematical operations, like adding numbers, for example. And this we call a parallelogram. This will give input data and output result. So this parallelogram here is where the user provides information, which is input data, or the program display and output a result. And you also have diamond lookalike shape, meaning this usually represent a choice or a yes or no path. And this is what I told you just now. It's a basic symbols in flowchart that you have to understand and remember very well. And we will do practice in the lab session before actually typing your code or writing your code in a C programming. You need to do flowchart algorithms based on the problem or question, exercise question, which are what are they to meet their requirements. So let's look at a quick example. If I ask you to write an algorithm to display hello world. Okay, so in a pseudocode algorithm, simply type begin and then print message and end. So that's how you write a pseudocode. For flowchart, you're going to draw an oval for the start part and print the hello world as input and end of the program. So this example also can be seen in the YouTube video on how to install the code block software that I put the link in the e-learning. So you need to watch the YouTube video. And then if we want to calculate the sum of two integers a and b, okay, but just ignore this one. Okay, you will begin by in a pseudocode you put input a and b in a parallelogram in a visual flowchart, and then you calculate a plus b. So this represent the process, the rectangle shape. Okay, processing, calculation, the mathematical notation like addition, subtraction, and then the print sum again in parallelogram as an output. And then you close the program with another oval shape with the end. So the closing recap for this topic, to wrap up, the foundation programming bridges the gap. The programming bridges human problems and computer execution. What is the logic? So all programs rely on algorithm, the step by step, what and when. And finally, the blueprint. The blueprint, we plan the logic using pseudocode and flowcharts before we ever touch a keyboard to actually write the program in the software. So I hope this gives you a clear roadmap about the introduction for this first week lecture. Okay, thank you and Assalamualaikum.